Center. The presenter is Alwinpoulosepalatty from Jeju University. Actually, he is from India. Please.
Thank you, Chair, for introduction. And my name is Alvin Paulos. I'm a PhD student from Kalman National University, Jeju. And today my paper is about indoor localization using PDR with Wi-Fi weighted path loss algorithm. So what you mean by PDR is localization using IMU sensor. That entire system we denote pedestrian networking system, and it is called as PDR. And for the Wi-Fi based localization system, we use RSSI signals and we estimate the position. Here in this paper, we consider the weighted path loss algorithm for estimating the user position using Wi-Fi RSSI signal. And in this paper, I proposed a algorithm to combine the PDR with the Wi-Fi weighted path loss algorithm. And during the presentation, I consider the motivation of the research and an introduction part of the localization system using PDR and Wi-Fi based localization system. And in the proposed system, we consider PDR positioning, Wi-Fi weighted path loss algorithm, and PDR with the Wi-Fi weighted path loss algorithm. For combining the PDR localization result with the Wi-Fi based localization system, we used linear Kalman filter. And we did some experiment to analyze the result, and we estimate some localization error, and we compare with the conventional method. In this comparison, we used individual positioning, or positioning from PDR and positioning from weighted path loss, and we just compare these results with the PDR with the weighted Wi-Fi weighted path loss algorithm, and some conclusion about my research. So motivation of this research, when we consider PDR based localization, pedestrian networking based localization, the main thing, the data, they are from IMU sensor, the data, the accelerometer, gyroscope, magnetometer sensors are used for localization purpose. And the major problem related to accelerometer sensor is the accumulated error. And when the experiment time increases, the error from accelerometer is very high and accumulate the error, and it reduces the position accuracy. And when we consider gyroscope sensor, the drift error, after when we do the experiment couple of times, after the next time there is a drift for the localization result. So that is another major problem related to PDR positioning. And when we consider the magnetometer based localization, the inside the system they have some magnetic field effect, and the surrounding systems they affect some external magnetic field disturbance. So these all are major challenges for PDR positioning. And when we consider for Wi-Fi RSSI based localization system, the first challenge is the signal fluctuation. The RSSI signals fluctuate from the Wi-Fi access point to the receiving module, and multipath effect, the major another challenge, a problem related to Wi-Fi RSSI based localization system. And the same signal interference, and the another major issue is we need a precise channel behavior model between Wi-Fi access point and the receiving module. In my experiment, I use the receiving module, my smartphone. Our smartphone, we have the RSSI receiving Wi-Fi receiving module. And the last major issue related to the Wi-Fi based localization system is sensitive to channel inconsistency. Anytime the channel can change, so that another serious issue. And to solve this problem, I proposed a localization system using the result from PDR based system and a Wi-Fi weighted path loss algorithm based system. So in the introduction, The localization, there are so many systems used for locating a position in indoor scenarios, and using PDR positioning is one of the most common and popular system and very easy to implement. And another is, these days we can see everywhere the Wi-Fi access points. So to use the Wi-Fi access point signals to estimate the current user position. So these are, for this research we consider the major two localization system, PDR and Wi-Fi RSSI signal based localization system. And I already discussed about the limitation related to both of the systems. So PDR, the system has drift error and accumulator error, and in the Wi-Fi the signal fluctuation and line of sight condition. So to overcome this limitation, we proposed a sensor fusion framework, and from the experiment result, the proposed system achieves an improving average localization accuracy of around 1.45 meter. So here is the proposed localization system. Here in the above part is the PDR system, localization using smartphone IUV sensor. Here we consider accelerometer, magnetometer, and gyroscope. And to avoid the DC offset values and noise from the accelerometer raw data, we used a bandpass filter. And using the accelerometer data, we first estimate the step detection. From the step, first step is to detect the user steps. From that detected steps, next is to identify the step length. Then using this step length, and here we consider a heading from magnetometer and a heading from gyroscope. To reduce the sensor error, we used a Kalman filter, a combined heading result from magnetometer and gyroscope. And final, the PDR position estimated using the heading information and step length information together. The PDR estimation algorithm finally estimate the position from PDR system. And in the case of Wi-Fi based system, we collected the data RSSI samples, and we used a conventional localization algorithm, a weighted path loss algorithm. And finally, here is we used a Kalman filter, and we combined the position result from PDR and a position result from Wi-Fi based system. Finally, we estimate the user current position. So in the case of PDR positioning, I explained first one is the step length estimation and pitch and roll estimation. This information, this data is used for heading estimation and position estimation. So these are the 4 steps related to PDR system. And in the first step length, we use this KIMS approach. It's a conventional method and proposed by the other KIMS. And using this information, here we define the K, not randomly, we do many times the experiment, and we estimate we fix a K value, and the AK indicates the acceleration XYZ values from bandpass filter. And here we estimate the pitch and roll angles estimated as the theta indicates pitch, sine inverse AY. AY is the y-axis from accelerometer, and G is the gravitational value constant is 9.8, and phi is the tan inverse AX by AZ. X value from the accelerometer, Y value from the accelerometer. And the next is the heading estimation from magnetometer. So for that case, we first converted the smartphone coordinate system into a globalized coordinating system. So here is the mathematical model for converting the smartphone coordinate system into globalized coordinate system, and we use the heading gamma denoted by gamma and tan inverse hy by hx, and same like we estimate the gyroscope heading from gyroscope sensor using quaternion update values. Here Q1, Q2, Q3, Q4 are Q0. From Q0 to Q3 are the quaternion updated values. And finally, the position is estimated using step length information and heading information. And in the weighted path loss algorithm, the first step is we consider free space path loss model is a common model to estimate the distance from access point to the user. So here STI denoted the RSSI value from the ith access point at time steps t, and the reference path loss coefficient and path loss exponent alpha and the distance, and from this equation we estimate the distance, derive the distance information, and finally weight of each access point can be estimated using this mathematical model. And finally, the location of the receiving module. In our case, it is smartphone, or the user holds the smartphone in his hand. So we assume that the user position. So here estimate the user position, x and y position. And here is the proposed Kalman filter algorithm. This is a basic linear Kalman filter implementation as compared to the extended Kalman filter or uncentered Kalman filter. For a simplicity and for real-time demonstration, linear Kalman filter is the best option. And here we consider the state vector, the state vector from the PDR system position values, and we predict the user position. We combine the z value is our observation metric is from the Wi-Fi access point, the position result from Wi-Fi based localization system, and finally we estimate the user position. And next is the experiment scenario. So here a skeleton map of experiment. Here we consider 4 access point in the 4 corner, and the user walked from the starting point 10 meter from here, and user walked around the indoor area, and the user the height around 172 centimeter and holding a smartphone in his right hand, and the smartphone Galaxy Note 8, and we collected the data, the RSSI data, and as well as we collected the IMU sensor data. And here we can see the first figure A shows the PDR result. The black mark indicates the PDR result. We can see there is a drift from the red line indicates the ground truth values, and there is a drift from the ground truth. This is due to the IMU sensor errors, accumulator error and drift errors. And when the second figure is the localization result from Wi-Fi based systems, Wi-Fi RSSI signals we estimated, and we using weighted path loss algorithm we estimated the final user position. And the last figure is our proposed method. Here we combined the result from PDR and result from Wi-Fi based system using a linear Kalman filter. And here to analyze the performance of the proposed system, we consider the root mean square error of position. First case is for the PDR system, second case is for the Wi-Fi based localization system, and last one is our proposed system. And next, the table summarized our overall result. The PDR system, the maximum exposition error is 2.541 meter, and the Y position is 2.678. And when we consider the Wi-Fi based localization system, the error is 1.625 and 1.708 x and y respectively. And when the proposed system PDR with the Wi-Fi path loss model system, the maximum position error is 1.403 from x position, and the y position is 1.454. So here for the next analysis we use the cumulative distribution function in the case of localization error, and here we can see the proposed model converging faster than as compared to the individual localization system. In some cases, the individual localization system shows similar localization error. And the end, our proposed method has less localization error as compared to the other two methods. And in the conclusion part, I propose a localization system by combining PDR with the Wi-Fi weighted path loss algorithm. And the error from the PDR system is 2.6 meter, and the error from Wi-Fi based system is 1.7 meter, and from the proposed method 1.4 meter. And in the future work, we consider the multiple user position for indoor scenarios. And in our experiment, we use a simple experiment situation, only a rectangular motion. But in future, we will consider zigzag motion or a circular motion, more complex motion of user and identify the user position. These are my presentation. Thank you.
Thank you. Any other questions?
So your final result is about two-dimensional, right? You estimate two-dimensional. Maybe PDR provides three-dimensional information, right? So you ignore the height, maybe.
Height is the height information. For that, we have to consider one more sensor, barometer. In this case, we use only three sensors. But if we consider the barometer, then we can identify which floor we are. We are in which floor, first floor, second floor, and professor asked about that or user position, user height.
But the Wi-Fi weight is something, right?
Yes.
PDR, you only use the one-dimensional distance from the user to the Wi-Fi AP.
Yes.
So it should be one-dimensional, right? Just
a distance value from access point to the.
So why don't you use the other, maybe, for example, the TDOA method or other positioning method?
Yes, the TDOA or time of arrival or angle of arrival.
Can use the street
that one usually in the case of Wi-Fi RCC based system usually the researchers just use the free space path loss model or triangulation algorithm and estimate the user position. But when we consider the UWB signals, like the UWB system, usually my research we do in the UWB system, we did time difference of arrival and time TOAN system. But in the Wi-Fi it is possible, but yes, but I didn't consider that area. This is a small part of the research. The next we proposed a deep learning approach to identify the user position. So this is a small part of the research. But in the Wi-Fi based localization, I didn't consider TOA or time difference of arrival.
Okay, thank you.
I have a question.
Yes.
In this slide, your heading method is how accurate or stabilization. I want to know the stabilization.
Stabilization.
Yes. Is
like
that good?
The heading.
Service?
Yes. If I can access the internet, I can show. I have the research. So heading estimation is.
It's not open access here actually.
It's open access. Sorry.
And then how about multiple user and multiple devices?
Multiple devices. When we consider the multi-user, we have to consider two devices. And for the PDR system, currently we are working on that, but not achieved like the multi-user, like current research only. Here I can show my heading estimation. Yeah, here is the heading estimation research. So here in the heading estimation, we proposed a method and compared with a conventional method. But in the proposed method, what we used is the heading from magnetometer and heading from accelerometer. So here, the starting position from here and one direction in the rectangular motion, one direction, and then we move. The next, this is the deviation, and again the straight motion, and again the deviation, and these are the red line, ground truth, and black, I think proposed, yeah, black is the proposed method.
One last question is regarding on Wi-Fi, the AP environment is very change day by day in real
situation.
Yes, yes. So, what how do you consider on that environment change?
Environment change, like multipath effect. Yeah, user multipath effect when we consider. To solve that multipath effect, one option is fingerprint based algorithm. So we have to do the multiple times the data collection. We just make, if we consider this indoor area, we make the fingerprints each location, each point. We collect the data, and then again we in the real time again we collect the data and we compare with the fingerprint maps and estimate the user position. That is the one option to overcome multipath effect that I know that maybe, and maybe the other method, one recent work is the protocol used for in the recent the smartphones, the Nexus 8 or something, they have FTP protocol. In that the Wi-Fi access provide time information. So that maybe we can solve for multipath effect. So these are the two things I can discuss.
Okay, thank you for your answer. Let's give a begin. Thank you.